Good morning. It's Engineer Heather there, trainer and director of Next Gen Technology. I warmly welcome all of you guys on my channel, Complex World. So today we are going to start our session on the topic of eigen values and eigen vector, that how to find the eigen values and eigen vector of a matrix. So the subject is linear algebra. So we will cover this example in our topic set. So we are going to find the eigen values and eigen vector of that given matrix, which is A matrix, and this is a 3 by 3 matrix. So before starting off my lecture, I request all of you guys to subscribe and share this channel with students, friends and family. I will also share my contact with you guys. If anyone of you have an issue, he she may ask. So let's start our topic, eigenvalues and eigenvector. So whenever you are given with the matrix, which is a 3 by 3 matrix, and you are supposed to find the eigenvalues and eigenvector, so you must have to follow 4 steps. So always remember what is the equation to find the eigenvalues and eigenvector. So the equation is a minus lambda I determinant equals to 0. So this is our equation to find the eigenvalues of a matrix. So in this equation we have A, which is given matrix, and lambda is an eigenvalue. Let's say we have an eigenvalue which is lambda, and I is an identity matrix. So for 3 by 3 matrix we have identity matrix 1 0 0 0 1 0 and 0 0 1. So this will be our 3 by 3 identity matrix. So let me write this equation, A minus lambda I for you. So here are the properties of eigenvalues, that what are the properties of eigenvalues of a matrix. So the first property is sigma I varies from 1 to n, a double I equals to sigma I varies from 1 to n lambda I. Lambda I is let's say we have n number of eigenvalues from a matrix. So lambda 1 plus lambda 2 plus lambda 3 up to so on plus lambda n. Yeah, by adding all the eigenvalues, when you add all the eigenvalues, you will get the same answer, which is the answer of adding all the diagonal values of a matrix. So addition of all the eigenvalues will give you the same answer, which is the addition of all the diagonal entries of your matrix. And the second one is determinant of your matrix. Let's say we have a matrix which is a matrix, and the determinant of your matrix is same like the multiplication of all the eigenvalues. Let's say we have 3 eigenvalues, 3 2 4, and you will get multiply 3 2s are 6, 6 4s are 24. So let's say we have product of eigenvalues 24, and we have, then the determinant of that matrix must be 24. So determinant of a matrix A, let's say we have a matrix A, and determinant of that matrix must be equal to the multiplication of all the eigenvalues. So by using the equation A minus lambda I, put the values A, which is the given matrix 3 1 4 0 2 6 0 0 5, minus lambda I is an identity matrix. So for 3 by 3 matrix we have this identity matrix. Now solve this matrix, multiply lambda with the identity matrix, you will get the first one is same like this, 3 1 4 0 2 6 0 0 5 minus lambda 0 0 0 lambda 0 0 0 and lambda. Now minus matrix A with that matrix, you will get the answer 3 minus lambda, you will get 3 minus lambda, 1 minus 0 1, 4 minus 0 4, 0 minus 0 0, 2 minus lambda, you will get 2 minus lambda, 6 minus 0 6, 0 minus 0 0, 0 minus 0 0, 5 minus lambda, you will get 5 minus lambda. So our step number 1 is complete. You have to find A minus lambda I first, to find the eigenvalues of a given matrix. So step number 1 is complete. The second step is find out the determinant of your answer. A minus lambda I determinant equals to 0. Now we have to find the determinant of that matrix first. So how to find the determinant of a 3 by 3 matrix? I hope you all guys are familiar with the determinant and properties and characteristics of determinant of a matrix. So I'm going to solve this step directly without explaining the determinant properties. You can see the determinant lecture before. starting the lecture of eigenvalues and eigenvectors. Okay, for determinant, the first one, when I write first one, 3 minus lambda here, you will get, neglecting the first row and the first column, you will get 2 minus lambda 6 0 5 minus lambda. 2 minus lambda 0 6 5 minus lambda. Then the minus sign, the second one, this one is a11, a12, a13, a21, a22, a23, a31, a32, a33. So for a12 with minus sign 1, now neglect the second column and the first row, you will get 0 0 6 5 minus lambda. Now a13 with the plus symbol, you will get, neglect the third column in the first row, you will get 0 0 2 minus lambda and 0. So evaluate all these, you will get 3 minus lambda. Multiply these two and these two with the minus symbol, 2 minus lambda, 5 minus lambda minus 0 6 are 0, minus 1, these you will get 0, minus 0, plus 4, 0 minus 0. Okay, by solving this equation, you will get 3 minus lambda, 2 minus lambda, 5 minus lambda. This whole bracket will become 0 and this whole bracket will become 0. You will get 3 minus lambda, 2 minus lambda and 5 minus lambda, which is equal to 0. Why equal to 0? Because we have equation a minus lambda equals to 0. Okay, now use these three brackets equals to 0, 3 minus lambda equals to 0, 2 minus lambda equals to 0 and 5 minus lambda equals to 0. By solving all these brackets, by comparing left hand side with the right hand side, you will get three eigenvalues. The first one is lambda equals to 3, the second one is lambda equals to 2 and the third one is lambda equals to 5. So these 3, 2 and 5 are our eigenvalues. Okay, the next step is how to find the eigenvectors. So these are the eigenvalues. This is lambda number 1, lambda number 2, lambda number 3. Now we are supposed to find the eigenvectors of on that values. Let's say I am going to pick out that value lambda 2 and I am going to find the eigenvector at lambda equals to 2. So what will be the equation to find the eigenvector? This is a minus lambda I x bar is a vector equals to 0. Okay, use lambda equals to 2. I am using lambda number 2 value. For example, I am using this eigenvalue lambda equals to 2 and find the eigenvector on that value. So we have to write this equation first, which I have solved there. A minus lambda I, which is equal to 3 minus lambda 1 4 0 2 1 6, which is 3 minus lambda 1 4 0 2 minus lambda 6 0 0 5 minus lambda, and x bar will be x y z equals to 0 0 and 0. So put the value lambda is equal to 2 in that equation. 3 minus 2 you will get 1 1 4 0. 2 minus 2 you will get 0 6 0 0 5 5 minus 2 you will get 3. xyz equals to 0 0 0. Now multiply these row with that column to get the equation. The first equation will become x plus y plus 4z. The second one will become 6z and the third one will become 3z equals to 0 0 0. From these two equations you will get z equals to 0. So the answer of the z is 0 from last two equations. So put the value of this z in equation number 1, you will get the equation x plus y equals to 0. Okay, how to find the value of x and y? We just have one equation left now. Substitute y equals to k1, you will get x plus k1 equals to 0. You will get x is equal to minus k1. Okay, now using these three values, z equals to 0, y equals to k1 and x equals to minus k1. Value of x is minus k1, y equals to k1, z equals to 0. Okay, take the k1 common. Okay, let me solve this here. K1 common, you will get minus 1, 1 and 0. So this is our eigen vector on lambda equals to 2.